So, hello everyone, welcome to this live session of 10 fantastic questions from the past year papers of IPMAT, the Integrated Program and Management Aptitude Test conducted by IIM Indore. I'm sure students of Standard 12th who are looking for a program of business management, an integrated program of business management, would definitely know about the IPMAT conducted by IIM Indore. This exam not only grants you entry into IIM Indore, but the scores are also considered valid by IIM Ranchi, the newly opened IPM program by IIM Amritsar, and by private institutes like the Nirma Institute and IIFT Kakinada, I think, and so on and so forth. There are a lot many institutes which consider the scores of the IPMAT conducted by IIM Indore. And the reason why I say IPMAT by IIM Indore is because IPMAT is also conducted by Rohtak, but the Integrated Program and Management Aptitude Test conducted by Rohtak is a separate paper, right? It's an altogether different paper, although the same nomenclature. So IPMAT IIM Indore is valid for a lot of different institutes, and as you would know, there are 3 sections to this paper, but only 2 subjects. So there are 2 sections on mathematics. One section is your standard multiple choice questions, MCQs, where +4 for a correct answer but -1 for a wrong answer, and of course no penalty for not answering the question. The short answer questions, however, are great, right? If you answer it correctly, you get points, you get marks, but if you do not answer it correctly, there is no negative marking. So for short answer questions, you can definitely take some risks. And of course, the third section is verbal ability or English, which is the multiple choice question format, because of which it does have negative marking. Okay, now IPM of IIM Indore, I'm just checking my messages also because this is a live session, so I'll be checking the responses I'm getting. So IPMAT IIM Indore, Indore considers the score, but it has the concept of section-wise cutoffs, which means it's not enough that you score enough marks overall, but you need to have scored a minimum score in every section, in each one of the 3 sections, to qualify for the next round, which is of course the personal interview. And then a composite score of what you have scored in the written test and your performance in the interview will give you a final score, which is considered for your admissions. Institutes like Nirma used to take just the overall score, but since last year, 2024, Nirma has also started considering these sectional scores. So it is very important that you score well in each and every section of this paper. And in my opinion, IPMAT by IIM Indore is one of the toughest papers because the level of questions is almost similar to the CAT conducted by the IIMs for admission to their postgraduate programs, right? And for a math nerd like me, these questions are absolutely fantastic. I love the questions that they ask because they are not calculation intensive. They check your fundamental knowledge of the topics on which the questions are based. So today in this session, I have put together a list of 10 fantastic questions from the past year papers of the IPMAT conducted by IIM Indore. These are all questions from the short answer questions, which means there are no options given to you. You just have to type in the answer. The best part is the answer, because you have to type in these answers, will always be an integer. No decimal points, no fractions, no squares, no roots, nothing. The answer has to be an integral number. And even if you get it wrong, there is no penalty, there is no negative marking. So either you get the marks for the question or you get a 0. There is no negative marking. So even if you want to take a risk, you can absolutely take a risk in these questions. So having said that, let's start. The past 4-5 years papers I have considered, and I have put up these questions. So starting with the IPMAT paper of 2021. The first question which I'm going to solve today in the top 10 is the sum. The sum up to 10 terms of the series 1.3 plus 5.7 plus 9.11 plus ... is what? The first thing that we need to understand is that the numbers are not 1.3, 5.7, 9.11. It seems a bit misleading. Actually, it is 1 multiplied by 3 plus 5 multiplied by 7 plus 9 multiplied by 11. You need to get that straight, right? If you think the numbers are 1.3, 5.7, then it's not going to make sense. But once you've understood, it's 1 into 3 plus 5 into 7 plus 9 into 11, so on and so forth till 10 terms. You have to find the sum of these 10 terms. Now, obviously, you can just write down the numbers 1.3, 5.7, 9.11 and identify what the next number in the series is going to be. But let's try to do this algebraically, right? So the concept which is being tested here is your fundamental knowledge of arithmetic progression. What is an arithmetic progression? So let us say the series 1, 3, 5, 7, 9, 11 and so forth. So 1 and 3, the difference, common difference is 2. 3 and 5, the difference is 2 and so on and so forth. So you have a first term, you keep adding the common difference and you get the next term of the series. So this question tests your knowledge on that. Now let's solve this question. So technically speaking, this question is nothing but 1 into 3 plus 5 into 7 plus 9 into 11, so on and so forth till 10 terms. So my first series is 1, 5, 9 and so on till the 10th term, and my second series is 3, 7, 11 and so on and so forth till the 10th term. So if I can identify what is the first series, what is the second series, my work is done. So let's work on each of the series individually. So my first series 1, 5, 9, here my first term is equal to A, is equal to 1 and my common difference is equal to 4, correct? So the nth term of the series is given by A plus n minus 1 into D. So here first term A is 1 plus n minus 1 and the common difference is 4. So that is 4. So this becomes 1 plus 4n minus 4, or I can define this as 4n minus 3. So let's keep this in mind. My first series can be defined as 4n minus 3. Brilliant. Now for the second series 3, 7, 11, my first term is 3 and my common difference is 4. So the nth term of this series is A plus n minus 1 into D again. So here A is equal to 3 plus n minus 1, common difference is 4. So that is 3 plus 4n minus 4, that is equal to 4n minus 1. So I have identified that the first series is nothing but 4n minus 3 and the expression for the second series is 4n minus 1. So all I have to do is find the summation sigma for I is equal to 1 to 10, or rather n is equal to 1 to 10, 4n minus 3 into 4n minus 1. If I'm able to find the summation of this expression, I should get the answer, because the value of n has to be taken as 10, because I have to find the sum of 10 terms. Easy, right? So I'm going to erase the things which are not required on the screen. Let's erase all this and let's work on this problem. So sigma 4n minus 3 into 4n minus 1 is nothing but sigma of n is equal to 1 to 10. Let's expand this. So 4n into 4n is 16n square. 4n into minus 1 minus 4n, minus 3 into 4n minus 12n. So minus 4n minus 12n minus 16n. Minus 3 into minus 1 is plus 3. So I just need to find the value of the summation of this particular series, and that becomes an easy question, because now I can spread this as sigma of, and I'm not going to write the expression just to make life simple, 16n square minus sigma of 16n plus sigma of 3. So the term 16 come outside, sigma n square minus 16 times sigma n plus sigma 3. So 3 times sigma, the number, that's sigma 1 actually. So now we know the formula. Summation of the first n square terms is given by n into n plus 1 into 2n plus 1 divided by 6. So this becomes 16 into n plus 1 into 2n plus 1 divided by 6 minus 16 times. Sigma n is n into n plus 1 divided by 2 plus 3 into sigma 1, but 10 times, so that is nothing but, let us say, sigma n. So now how do we proceed from here? Absolutely easy. I just know that the value of n that I have to use is 10. So this becomes 16 into 10 into 11 into 21 divided by 6 minus 16 into 10 into 11 divided by 2 plus 3 into 10. That's it. I just need to find out the value of these numbers and that gives me my answer. Let's simplify it. I'm not going to leave you hanging, right? I'm going to solve this. So 6, let's divide it. So 2 3s are, 2 8s are, 3 1s are, 3 7s are. So this is 8 into 10 into 11 into 7. So 8 7s are 56. 56 into 11 is 560 plus 56, which is 616. So into 10 gives me 6160 minus 2 8s are, 8 11s are 88. This becomes 880 plus 3 into 10 gives me 30. So 6160 plus 30 is 6190 minus 880. So 0 minus 0, 0, 9 minus 8 is 1, 61 minus 8 is 60 minus 7 is equal to 53. And I have got my answer that the sum of the first 10 terms of this series is 5310. Right? I wouldn't say this is an absolute sitter, the expression which I use for many of the questions. But yes, it is definitely something which is doable. All you need to do is understand what is the formula for the summation of the first n square terms, summation of the first n terms, and work out what is the expression here. Of course, if you take it as 1.3, 5.7, 9.11, 9.11, it's going to be confusing, right? That is a bit of an error which I accept that the question framer has set, but people who know maths would understand that this is how series are represented. I hope everybody understood the funda of this question. Easy one, definitely solvable under 3.5 minutes, which is the average time you get to solve each question, assuming that you take the same time for each question, right? So the first question, and this was from IPM 2021, and short answer question. So even if you mark the wrong, even if you write the wrong answer, it's not going to incur any penalty. Absolutely good. Chalo. So that was the first question from IPMAT 2021, one of my favorite questions from all the past year papers of IPMAT IIM Indore. Okay, now let's go to the next question. Now this is a very involved question, right? This is again from IPMAT 2022, a short answer question of mathematics, which says, the third, 14th and 69th terms of an arithmetic progression form 3 distinct and consecutive terms of a geometric progression. Wow. Concepts of both AP, arithmetic progressions, and GP, geometric progressions. Fine. Now, if the next term of the geometric progression is the nth term of the arithmetic progression, then n equals what? Now, most of the students would give up this question by the time they have completed reading this question. But believe me, although it is laborious, it's not a difficult question to solve, right? We just need to use our fundamental concepts of AP and GP and take it step by step. So, let's see how this can be done. Okay, step 1. It says that the third, 14th and 69th term of an AP, okay, let's stop there. I know that the nth term of an AP is A plus n minus 1 into D, where A is my first term of the series and d is the common difference of that particular series, right? And n is the nth term. So what information do I have? It is given that I have the third, 14th and 69th term. So the third term is a plus 3 minus 1 into d. So that is a plus 2d. I have got the 14th term. So the 14th term is a plus 13d. And I have got the 69th term of the series. So the T69 is a plus 68d. So I can represent algebraically these three terms. Okay, fantastic. Now let's move on ahead in the problem. It says that these three terms are three distinct and consecutive terms of a GP, consecutive terms of a geometric progression. How is that going to help me? So let's understand a geometric progression first. A geometric progression, okay, I seem to have pressed something, don't worry. So T3 is a plus 2d, T14 is equal to a plus 13d, and T69 is a plus 68d. Fantastic. Now, in a geometric progression, you take a first number a and you keep multiplying it by the same number, which is known as the common ratio or r. So if the first term is a, the second term is a into r, the third term a into r or ar square, fourth term a into r or ar cube, and so on and so forth, which means the second term upon the first term is the same as the third term upon the second term, and so on, right? Everybody knows this about a GP. And I know that T3, T14 and T69 are three consecutive terms of a GP. That means that if I take T14 upon T3, the ratio should be the same as T69 upon T14, right? So let me substitute it with the values as in the AP. So T14 A plus 13d upon a plus 2d is equal to a plus 68d divided by a plus 13d. Great. So now if I take cross multiplication of the terms, I get a plus 2d into a plus 68d is equal to a plus 13d into a plus 13d, which is nothing but a plus 13d the whole square. Okay, let's expand these terms. So a plus 2d into a plus 68d, I get a square plus a into 68 is 68ad plus 2d into a. So that is 68ad plus 2ad, that is 70ad plus 68 into 2, so that is 136d square is equal to a plus 13d the whole square. So a square plus 26ad plus 169d square. I hope you are able to see the things. Let me darken the pen a bit. Okay. So a square plus 70ad plus 136d square is a square plus 26ad plus 169d square. Let's simplify this further. So the a square gets cancelled on both the sides. Nice. 70ad minus 26ad is 44ad, which is 169d square minus 136d square, which is 33d square. So the d again gets eliminated on the both sides. So if I have 44a is equal to 33d, then this is 4a, this is 3d. So a is equal to 3 upon 4d. The first derivation which I have got is a is 3 by 4d. Let's keep it aside. A is equal to 3 upon 4d. Okay. A lot of hard work, right? Okay, I think you're not able to see that on the screen. So let me put it. A is equal to 3 upon 4d. This is the derivation which I got. Great. but I still haven't read the entire question. So let's move further. What does the question say? If the next term of the geometric progression is the nth term of the arithmetic progression, okay? So the nth term of the arithmetic progression is a plus n minus 1 into d, and that is equal to the next term of the geometric progression. Okay, so the geometric progression's last term as of now is a plus 68d. So the next term is a plus 68d into the common ratio r. Great. But what is the common ratio r? So common ratio r in this case is nothing but the second term, which will be a plus 13d upon the first term, which is a plus 2d. So in this case, I can replace the value of r with a plus 13d into a plus 2d. So let's do that. So here I write a plus 13d upon a plus 2d. Great. So now I have got an equation with two variables, right? A and d. But in this case, the best part is I also have the equation a is equal to 3 by 4d. So all I have to do is simplify both of these things. So what am I going to do? I'm going to replace every value of a with 3 by 4d. So now I get the left hand side 3 upon 4d plus n minus 1 into d is equal to 3 upon 4d plus 68d into 3 upon 4d plus 13d, the whole divided by 3 upon 4d plus 2d. Now this looks like a daunting task, but believe me, step by step we'll go ahead solving this and we will reach somewhere. Let's see that. Okay, so the left hand side I take the d common, so this becomes d and I get 3 upon 4 plus n minus 1. That's it. On the right hand side, every expression has a d in it. So let's take out the d's. So the first expression is d into 3 upon 4 plus 68. The second expression, again I have a d and 3 upon 4 plus 13 upon, again I take out the d common, I have got 3 upon 4 plus 2. Now a lot of d's, but all of them can be cancelled. So a d and a d out, d and a d out. So I have eliminated all the d's. All I'm left with is a lot of constants and n. So now life becomes extremely simple. What I need to do is simplify this particular expression. Okay. So I get 3 upon 4 plus n minus 1 is equal to 3 upon 4 plus 68 into 3 upon 4 plus 13, the whole divided by 3 upon 4 plus 2. Okay, let me clear up the screen a bit. Now we just have to simplify this expression. And again, I'm not going to leave you to do it. I'm going to show you. So 3 upon 4 plus n minus 1. So this, the left hand side becomes n. 3 upon 4 minus 4 upon 4 is minus 1 upon 4, which is equal to, so the 4 is common everywhere. So 68 into 4 is 240 plus 32, 272. So this becomes 3 plus 272 the whole upon 4 into 13 4s are 52, 3 plus 52 upon 4, 4 2s are 8, 3 plus 8 upon 4. Now even the 4s can be eliminated, but here n is not upon 4. So let's first convert this into an upon 4 term. So n minus 1 upon 4 can be written as 4n minus 1 the whole upon 4. So 4 and 4 out, 4 and 4 out. Yay! So I get 4n minus 1 is 272 plus 3 is 275 into 3 plus 52 is equal to 55 divided by 3 plus 8 is equal to 11. Life is so easy. 11 ones are, 11 fives are. So what is 275 into 5? 275 multiplied by 5. 5 fives are 25. 5 sevens are 35, 37. 5 twos are 10. 1375. So 4n minus 1 is 1375. 4n is 1376. So the value of n is 1376 by 4, which is 4 threes are 12, 4 fours are 16, 4 fours are 16. So I finally get the value of n for this particular question as 344. Let me check my notes. Yep, 344. Absolutely lengthy question. Of course, it took me so much time because I'm explaining it. But if you have the time, and believe me, the average time the average time available to solve each of the questions is about 3.5 to 4 minutes. And when you're not talking at all out, when you're just writing it down and using a lot of shortcuts, you will definitely be able to solve this question under the time of 4 minutes. Definitely worth solving, right? This was from IPMAT 2022. Long question, but it could have been solved. Great. Now let's move on to the next one. A question from IPMAT 2023. And functions is a favorite chapter of whoever sets the paper of IPMAT Indore, right? You definitely will get a couple of questions. So here it says if f of 1 is 1 and f of n is defined as 3n minus 5 f of n minus 1 for all integers n greater than 1, then find the value of 2023. And believe me, f of 2023 would have been from the 2023 paper. In 2022 paper, you would have some functions question where you have to find f of 2022, right? IPMAT has this favorite thing. And because we know that they have the tendency to set such questions, you should also know how to work out these questions. And believe me, the method to work out this question is also absolutely easy. It's not difficult to work out the answer to this particular question. So let's see how to do this. And believe me, again, it's a brute force attack to be doing this. Okay. So I know that f of 1 is defined as 1. Okay. What about f of 2? So we'll use this definition of the function. F of 2 is 3 times 2 minus f of 2 minus 1. So 3 times 2 is 6 minus f of 1 is 1. So I get the value as 5. So f of 1 is 1, f of 2 is 5. F of 3 is 3 times 3 minus f of 3 minus 1, 2. So this is 9 minus 5, which is equal to 4. F of 4 is 3 times 4 minus f of 3, which is 12 minus 4, which is equal to 8. F of 5 is equal to 3 times 5 minus f of 4, which is 15 minus 8, which is equal to 7. F of 6 is equal to 3 times of 6 minus f of 5, which is equal to 18 minus 7, which is equal to 11. And before you start thinking I'm going to work out every single value of f till 2023, no. What I'm trying to do is establish a pattern, right? So I have got 6 numbers, 1, 5, 4, 8, 7, 11. And prima facie, it looks as if there is no connection. But on closer inspection, you will be quickly able to identify that alternate numbers are actually in pattern. So 1, 4, 7. So this is 1 plus 3, 4, 4 plus 3, 7. And if you work out f of 7, you will get the next number as 10. Similarly, all the even numbers 5 plus 3, 8 plus 3, 11 and so on. So I get that the odd numbers are going in the odd terms are going in the sequence 1, 4, 11, so on and so forth, right? So for odd terms, the series is 1, 4, 7, so on and so forth. Okay. Now, I need to find out f of 2023, which is an odd number, and that's why I used the odd numbers. I didn't consider the even numbers. Okay, so the first term is 1 in this series. The second term is 4. Beg your pardon. The second term in this case was 4. The third term was 7. So using the concept of AP, A plus n minus 1 into D, first term 1 plus n minus 1, common difference 3 is 1 plus 3n minus 3. So that is 3n minus 2. So the nth term of the series is 3n minus 2. So 2023rd term, if it is 3n minus 2, then 3n is equal to 2025, which implies n is equal to 3 6 are, okay, hold on. Let's not get ahead of ourselves. So step by step we need to do this. So I have identified that the series is nothing but 3n minus 2. Is it 3n minus 2? Yep, the series is 3n minus 2. So now the series, the first term is n, the second term, so these are all odd terms, right? These are all odd number, every odd term. So the first number, so 2n minus 1 is the expression for an odd number. 2n minus 1 is the expression for an odd number. So if n is equal to 1, then 2 into 1 minus 1 is 1. N is equal to 2. So 2 into 2 minus 1 is 3. N is equal to 3. So 2 into 3, 6 minus 1 is 5, and so on and so forth. So 2023 is 2n minus 1, which means 2n is equal to 2024, which implies the nth term is 1012. 1012. Great. So now that I have identified the value of n which I have to solve is 1012, the nth term can be given by Tn is equal to 3n minus 2. So the value is 3 into 1012 minus 2, which is 3036 minus 2, which is 3034. So the 2023rd term where n becomes 1012 will give me the value from the function as 3034. So the value of this function is 3034. Right? A little bit complicated, got a little bit jumbled at the end. But if you think about it carefully, you will definitely get the answer to this question, right? So the trick to solving it is, because you know the definition of the function, work out the first 6-7 terms, f1, f2, f3, f4, and automatically you will definitely see a pattern emerging from it. And once you see the pattern emerging, it's simply a concept of applying either an arithmetic progression in 99% of the cases, or very rarely a GP, but mostly it will be an AP. And you know the concepts of AP. So this question, absolutely solvable. Tiring, man. Great, but that's why it's one of my top favorite questions. Okay, now this question is an absolute doozy, right? It's a very, very simple question where you are given a polynomial of the degree 10, 4 into x to the power 10 minus x to the power 9 plus blah 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 blah, so many terms, and you are asked that when it is divided by x minus 1 and leaves a remainder 2, then what is the value of c plus 6, because one of the coefficients is c. If you think this is a tough question, believe me, it's not. It's an absolutely easy question to solve. Remember, when something is divided by a number and leaves it 0, then the value of, when you substitute, let's say x minus 1 perfectly divides it, right, and leaves the remainder 0. Then the value of x minus 1 is 0, means I substitute the value of x as 1 in the expression and it is equal to 0. But x minus 1 leaves the remainder 2, which means if I take the value of x is equal to 1, the entire expression is equal to 2. That's it. So all I have to do in this problem is assume the value of x to be 1. And I know 1 raised to any power is 1. So all I have to do is write the coefficients, right? So I say 4 into x to the power 10 is 1. So 4 minus 1 plus 3 minus 5 plus c plus 2 minus 1 plus 1 minus 4 plus 6 minus 2, and it leaves a remainder of 2, so the entire expression is equal to 2. That's it. It's actually that simple. Let's just add and subtract these numbers. So 4 minus 1 is 3 plus 3, 6 minus 5 is 1 plus c. So c plus 1. So 1 plus 2 is 3 minus 1 is 2 plus 1 is 3 minus 4 is minus 1 plus 6 is 5 minus 2 is 3. So c plus 3 is 2, c is equal to 2 minus 3 minus 1. And remember, you don't have to find the value of c. You are asked what is the value of c plus 6. So minus 1 plus 6 is equal to 5. You type in the answer 5, you get the full marks for this question. So questions which look that complicated are actually that simple, right? And I have some question. When will the registration end? If you're asking for the registrations for the IPMAT 2025, then off the top of my mind, I don't recall the exact dates for that. But please go to the official website of IIM Indore, that is iimidr.ac.in, and the registration dates are given there. But most of these entrance examinations usually begin their registrations in mid-Jan and finish by end of March, mid or end of March. And as we are already over the mid of March, so they could be ending anytime soon. I think somebody mentioned 27th as the date. But please go to the official website of IIM Indore and check, because the registration, the last date for registration for IIM Indore's IPMAT is actually not very far away. Please go to the official website and check. Don't rely on third-party websites. Go to the official website and check. I don't think much time is left for the registrations. Okay. Those are the questions. So that was an absolute easy question. Looks complicated, IPMAT 2023, but very easy to solve. Okay. Ooh, this is again a question which looks tough, but is an absolute sweetheart question. The remainder when 1 factorial plus 2 factorial plus 3 factorial plus ... till 95 factorial is divided by 15. Believe me, all you need to understand is how factorials work, how remainders work. Okay, so a quick refresher on what the concept of factorial is. N factorial is defined as n into n minus 1 into n minus 2 till 3 into 2 into 1. You keep on multiplying while reducing the number by 1 till you reach 1. So 5 factorial would be 5 into 4 into 3 into 2 into 1, which is equal to 120. 3 factorial will be equal to 3 into 2 into 1, which is equal to 6. 1 factorial will be 1, and you have to just know this, that 0 factorial is also defined as 1, although not relevant to the question. Okay, understood what are meant by factorials? Now, the question itself says that I'm adding all the factorials and it is then divided by 15. Okay, so 1 factorial is equal to 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. So far so good. But now the fun begins. 5 factorial is 5 into 4 into 3 into 2 into 1. And when I divide this by 15, 5 3s are, 3 1s are. 5 factorial is perfectly divisible by 15. Similarly, 6 factorial is 6 into 5 into 4 into 3 into 2 into 1 divided by 15. 5 3s are, 3 1s are. Perfectly divisible by 15. So obviously, 5 factorial onwards, every number is perfectly divisible by 15. It's not going to leave any remainder, which means this problem actually boils down to what is the remainder when 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial is divided by 15, because every other number is perfectly divisible, leaves no remainder. And I've already given you the value of these numbers. So 1 factorial 1, 2 factorial 2, 3 factorial 6, 4 factorial 24 divided by 15. 1 plus 2, 3 plus 6, 9 plus 24 is 33. When divided by 15 gives me the remainder 3. That's it. Right? So it's a basic funda that every number, when you are dividing and these are remainder, the summation, you add the remainders, and that also divided by the same number will have the same effect, something called the remainder theorem. Right? I'm not, of course, going to explain the entire remainder theorem, but I'm sure IPMAT aspirants know this. So this problem actually only forces you to think that are there certain numbers which don't need to be included in the calculation? And the answer is yes. 5 factorial and onwards, every number is divisible by 15. So it's just 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial divided by 15. And that is your answer, right? So very, very fundamental question and lovely question. And though it seems like a difficult one, it was actually solvable in hugely under a minute, right? Unlike the previous ones which involved a lot of calculations, this one did not even have that much of calculation in it. And this was IPMAT 2023. Okay, let's move ahead. 2023, yet another problem. Now this one is going to be slightly long, right? The basic concept of time, speed and distance is tested in this particular question. But what you need to understand is that it is not as easy as it looks, not in terms of difficulty, but there are a lot of calculations involved in this, right? So here, let's see, and what I'm looking at is just my notes. Okay. It says, Vinita drives a car which has four gears, and you're given the ratios of the speeds of the gears, time taken, so on and so forth. So let's go step by step. Step 1, the fundamental formula for time, speed and distance. Speed is equal to distance upon time, or time is equal to distance upon speed. That's my fundamental formula which I'm going to follow. Okay. Now, Vinita drives a car which has 4 gears. Speed of the car in the 4th gear is 5 times speed in the 1st gear. Okay. So, speed of the car in the 4th gear S4 is 5 times the speed in the 1st gear. So, if I take S1 as speed in the 1st gear, S2 as speed in the 2nd gear, S3 as speed in the 3rd gear, and S4 as the speed in the 4th gear, then S4 is 5S1. That's my first ratio given. Okay. The car takes twice the time to travel certain distance in the 2nd gear compared to the 3rd. So remember, speed is inversely proportional to time. So in the 2nd gear, if it takes twice as much time, then the 3rd gear is, the speed in the 3rd gear is twice as much in the 2nd. So the speed in the 3rd gear is twice the speed in the 2nd gear, because speed and time are inversely related. So now I've got two relations. S4 is 5S1, S3 is 2S2. So far so good. Now, in a 100-kilometer journey, if Vinita travels equal distances in each of the gears, and remember there are 4 gears. So in each gear, she has traveled 100 by 4, 25 kilometers. Then she takes 585 minutes to complete the journey. So the time for the first quarter plus the second plus the third plus the fourth is equal to 585 minutes. So this is equal to 585. And I know time is distance upon speed. So in each case, the distance is the same, 25. So 25 upon S1 plus 25 upon S2 plus 25 upon S3 plus 25 upon S4 is equal to 585. But I also know that S4 is 5S1 and S3 is 2S2. So I can rewrite this as 25 upon S1 plus 25 upon S2 plus 25 upon S3 is replaced by 2S2 plus 25 upon S4 is replaced by 5S1 is equal to 585. And the 25 in the numerator is common. So I can take it to the other side. So I can write 1 upon S1 plus 1 upon S2 plus 1 upon 2S2 plus 1 upon 5S1 is equal to 585 upon 25, and I'm not going to simplify it. I hate simplification in middle of the problem. I leave it for the end. So let's just put this together. So 1 upon S1 plus 1 upon 5S1, that is equal to 6 upon 5S1 . So 6 upon 5S1 plus 1 upon S2 plus 1 upon 2S2 is 3 upon 2S2 is equal to 585 upon 25. I can also take out a 3 common here and put it on the denominator on the other side. So I get 2 upon 5S1 plus 1 upon 2S2 is 585 upon 3 into 25. Looks like a weird thing, right? So let's keep it aside for the moment. I'm going to erase certain things on the screen, but keep the relevant part here. Okay. So I have 2 upon 5S1 plus 1 upon 2S2 is 585 upon 3 into 25. Okay. Can't do anything further than that. So let's proceed with the question. Instead, if the distances covered in the first, second, third and fourth gears are 4, 4, 32 and 60 kilometers respectively, then what is the total time taken? So again, T1 plus T2 plus T3 plus T4, and speed is equal to distance upon time. So time is equal to distance upon speed, and I know that distances are given. So the first distance is 4 upon S1, second distance again 4 upon S2 plus third distance 32 upon S3 plus fourth distance 60 upon S4. I need to find the value of this expression, and somehow this should come in handy. Okay, I already know that S1 S4 is equal to 5S1 and S3 is 2 times S2, right? So let's replace that. 4 upon S1 plus 4 upon S2 plus 32 upon 2S2 plus 60 upon 5S1. Great. Let's simplify where possible. So 2 ones are, 2 16s are, 5 ones are, 5 12s are, and club similar terms together. So 4 upon S1 plus 12 upon S1 plus 4 upon S2 plus 16 upon S2. So this is equal to 16 upon S1 plus 20 upon S2. Now, how do I reach one from the other? I seem to have lost the equations. So I'll have to refer to my notes. Okay. So 4 upon S1 plus 4 upon S2 plus 32 upon S3 plus 60 upon S4. I have 4 upon S1 plus 4 upon S2 plus 32 upon 2S2 plus 60 upon 5S1. So this is 2 ones are, 2 16s are, 5 ones are, 5 12s are. So 4 upon S1 plus 12 upon S1 plus 4 upon S2 plus 16 upon S2, which is equal to 16 upon S1 plus 20 upon S2. Also, I had the expression that 2 upon S1, 2 upon 5S1 plus 1 upon 2S2 was equal to 585 upon 25 into 3. So if I transform this into this, I can definitely get it. So to get 16 upon S1 as 2 upon 5 S1, let's multiply and divide by 2 upon 5. So 2 upon 5 into 5 upon 2 into 16 upon S1 plus I need 1 upon 2. So 1 upon 2 into 2 upon 1 into 20 upon S2 into 20 upon S2. I hope that's the expression. Okay. So if I simplify this, I get I need 2 upon 5. So I need 16 upon S1 and I need to convert into 2 upon 5. So the remaining portion 2 8s are. So this becomes 40 times 2 upon 5 S1 plus 40 times 1 upon 2S2. Great. So if I take the 40 common, right? Let me eliminate some part of the screen. Okay. So if I take the 40 common, then I get 2 upon 5S1 plus 1 upon 2S2, and that's the expression here. So this is 40 into 585 upon 25 multiplied by 3. That's it. And once I simplify this, my answer will be 312. Sometimes I do have to refer to my notes because some glitch and I lost my calculations on the screen. But you can work it out, right? So again, this is a laborious question. It's just a laborious question. It's not a tough one, but it's definitely a laborious question because you need to go through the things step by step, one by one. Okay. I seem to have a few more questions here. Okay. The way you explain makes it really the question are crack. Oh, great, great, great. So I love it when I get comments like that, that I make it seem the questions are crackable. Believe me, every question is crackable. All you have to do is not be afraid of the question and be thorough with your fundamentals. Okay. So that was the 23 question, lengthy, and every year you get one of these time span and distance questions which are absolutely, I wouldn't say easy to crack, but definitely doable. Okay. Oof. Now we move on to the next one, and this is definitely an involved question. It says the product of the roots of the equation log of 2 raised to log x base 2 square base 2 minus 5 log x base 2 plus 6 is equal to 0 is equal to what? Now that is one hell of a doozy, right? Okay, but easy because the first thing I observe is log x to the base 2 seems to be a common expression. So let me assume log x to the base 2 is equal to a, right? So this question becomes log 2 to the base 2, and this is 2 raised to a square minus 5a plus 6 is equal to 0. So log of something to the power becomes the coefficient. So a square log 2 to the base 2 minus 5a plus 6 is 0, and log of any number to the same number as the base is 1. So this is a square minus 5a plus 6 is equal to 0, right? So now I'm left with a square minus 5a plus 6 into 0. So a minus 2 into a minus 3 is 0, which means a is either 2 or a is 3. But that's not the answer, because I had assumed that log x to the base 2 is a. So either log x to the base 2 is 2 or log x to the base 3 is 3, which means x is equal to 2 square or x is equal to 2 cube. And once I get that expression, x is either equal to 4 or x is equal to 8, and I have to find the product. So 4 into 8, I get 32. So product of the roots is equal to 32. That's it. If you know the fundamentals of quadratic equations and you have the presence of mind to find that log x to the base 2 is the common term and substitute it with a common variable a, then it becomes an easy question to solve. And this was IPMAT 2023 once again. Okay, comments 3 and 2. Okay, great. So the product of the roots of this equation, definitely a good question to solve, right? Fun question to solve. All right. Ooh, now I remember this question because I was discussing this question at home to my mom and my wife, and they were just disinterested but polite enough to pay attention to what I was saying, right? I was boring them with how I cracked this question and how fundamental it is and so on and so forth. Okay. So it says the number of real solutions of the equation expression raised to an expression is 1 is what? This question actually requires you to understand some fundamentals, right? How do you get the value of a power indice as 1? So either any number raised to 0 is equal to 1, or 1 raised to any number is equal to 1, or minus 1 raised to an even power is equal to 1. There are only 3 possible cases where the power of a number is equal to 1. So either the value of the power, the indice itself is 0, or the base itself is 1, or the base is minus 1 and the power is a even number, right? So I have to work out these 3 cases. Okay, so let's see how it works. First case, let's assume that the power is 0. So if x square minus 5x plus 6 is 0, then x minus 2 into x minus 3 is 0, which means x is either 2 or 3. That's it. Easy. So these are 2 possible roots, 2 and 3. Now a second case, let's assume that the base is 1. So if I get x square minus 15x plus 55 is equal to 1, then x square minus 15x plus 54 is 0. So how do I get 54? How do I split the terms? 9 6 are 54. Okay. So x square minus 6x minus 9x plus 54 is 0. So x into x minus 6 minus 9 is equal to 0. So the value of x can be equal to 6 or 9. So as of now, I have got 2, I have got 3, I have got 6 and I have got 9. I have got 4 possible values. But that's not the end of the question. There is one more possibility, that the base is minus 1 and the power is even. So let's see how we work that out. Okay. So what is the condition? The base x square minus 15x plus 55 is equal to minus 1, which means x square minus 15x plus 56 is 0. 7 8s are 56, so x square minus 7x minus 8x plus 56 is 0. So x into x minus 7 minus 8 into x minus, so x is either 7 or 8, but here I need to verify that when x is 7 is the power even, when x is 8 is the power even, and very easy to do that. I don't need to simplify it, I can use some logic. Let's assume x is 7. So x square is 7 square. Odd number minus 5 into 7 odd. Odd minus odd is even plus even. So if x is 7, the power is even. So 7 definitely works. What about x is 8? So 8 square is even, minus 5 into 8 is even, even minus even is even, plus 6 even. So even with 8, this is definitely an even number. So the power for both 7 and 8 definitely are even. So then I have got 6 possibilities, either 2 or 3 or 6 or 9 or 7 or 8. Any one of these 6 numbers can satisfy the equation, and that is your final answer, right? But very, very brilliant question, because it tests you on the fundamentals of numbers. You should be quick to identify that any number raised to 0 is 1. 1 raised to any number is 1. But the last case, that a negative base raised to an even power is also equal to 1. Right? Once you've identified these 3 scenarios, you get the answer, 6 possible answers to this particular expression. Great. Shall we move on? This was 2024, last year's paper. Great. A question which took me some time, but once I got it, at least 2 different ways in which it can be solved. The number of pairs of x comma y of integers satisfying the inequality mod x minus 5 plus mod y minus 5 is less than or equal to 6. I need integral values of x and y such that x minus 5 plus y minus 6 modulus values of both the numbers is less than or equal to 6. Let's make our life a bit simple, right? Let's simplify this expression. Logically speaking, if I assume x minus 5 to be equal to a, then x is nothing but a plus 5. So for every unique value of a, I will get a unique value of x. Similarly, if I assume y minus 5 to be b, for every unique value of b, I can find a unique value of y. So why not simplify this equation as mod a plus mod b is less than or equal to 6. So the number of values of a and b will be the same number of values of x and y. So I have got rid of the minus 5 portion, right? My equation simply is this. So how many values of a and b can satisfy this? And mod means positive values. So a and b are nothing but ranging between 0 to 6 inclusive. So 0, 1, 2, 3, 4, 5, 6. So all I need to do is form the number of pairs of a and b where the sum is 6. Correct? So a positive or a negative value, both are possible, because mod of 1 is also 1, mod of minus 1 is also 1. Okay. So having identified that, right, I have to work with mod a plus mod b is less than or equal to 6. So to make life easy, I'm first going to work with non-zero values, right? So I have got a, what are the corresponding values of b? So a, I'm taking non-zero values. So a can be 1, 2, 3, 4 or 5. Not 6, because I'm only considering non-zero values. So if I consider 6, b becomes 0. Okay. So when a is 1, b can be 1, 2, 3, 4 or 5, right? When a is 2, this can be 1, 2, 3 or 4. For 3, 1, 2 or 3. For 4, 1 or 2. For 5, 1. So 1 plus 1, 2 less than or equal to 6. 1 plus 2, 3 less than or equal to 6. Till 1 plus 5, 6 less than or equal to 6. And for every value, 2 possibilities, either positive or negative, because mod of 1 is 1, mod of minus 1 is also 1. So here in each case, I have got 2 possible values. Similarly, for each case, for 5 different values, plus minuses, total 10 values, 8 values, 6 values, 4 values and 2. So how many combinations are possible? 2 tens are 20, 2 eights are 16, 2 six are 12, 2 fours are 8, 2 twos are 4. So 20 plus 16, 36, 36, 48, 48 plus 8, 56 plus 4. A total of 16 non-zero pairs are possible. But now I can also have one of the values is 0. So if A is equal to 0, then for B, I can have all the values from 1 to 6. So total 12 values, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3, till plus 6, minus 6. And only one value of 0 because there's no positive, negative. So with A 0 and B non-zero, 12 possible values. Similarly, with A non-zero and B equal to 0, 12 possible values. And then both A and B can be 0. 0 plus 0 is 0 less than or equal to 6. So that is one combination. So 60 plus 12 plus 12 plus 1. 72, 84 plus 1. I've got a total of 85 numbers which are absolutely possible in this example. So the answer is there are 85 solutions. Now you'll have to give me a minute. I will take a short break for a couple of minutes and come back and show you the second way of solving this. Hello, I'm back. So I hope you understood the first way of doing this problem, right? I work out all the possible values of A and B. But when working on this problem, it got me thinking, is there another way in which I can crack this problem? And I got a graphical method of solving this. So let's see how graphically this can be done, right? Okay. So I'm going to yet again rely on mod A plus mod B is less than or equal to 6. Now, what does this mean? The extreme values, right, are nothing but 0 and 6, 0 and minus 6, 6 and 0, and minus 6 and 0. These are the extreme possible values. All other numbers are in between 1, 2, 3, 4, 5 and combinations. So how many such combinations are possible? So if I draw this as a graph, right? So I can have 1, 2, 3, 4, 5 and 6 top value here. 1, 2, 3, 4, 5 and 6 bottom here. 1, 2, 3, 4, 5 and 6 max left. 1, 2, 3, 4, 5 and 6 max right? And if I draw the lines connecting this, then all my solutions, because they are less than or equal to it, should fall within this range. Now, how do I find that number? So what I'm going to do is actually I'm going to construct the graph here, right? So let's see. I'm going to draw all these lines. This is just to make life a bit simple. So bear with me for a moment. I'm actually going to show you how this diagram is going to work. It's a brute force method, but it actually works. Okay, what I have to do is simply identify how many of these lines which intersect, how many intersection points lie within this. And believe me, it's easy to just count them, and symmetry helps. So I have got 1 point, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35 and 36. I'm not counting the middle axis, right? So because I've got 36 points on top, I will have corresponding 36 points in this range. That is a total of 72. And then the axis itself, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So a total of 85 points lie in the graph. Such a silly, I mean, it looks silly, but if you understand the funda, right? Mod x plus mod a plus mod b less than or equal to 6 is nothing but a symmetrical enclosure within a enclosure on a graph. So if you count all the points inside the enclosed shape, then that is nothing but the number of solutions, and you can literally count these solutions and it works out to 85, and that is the answer to this question. So either you could use the funda of finding out the combination of numbers or drawing something like this and simply counting it. Either way, we get the same number, that the number of possible solutions in this case is equal to 85. Okay, brilliant. Which brings me, I think, to the last question in the series. Absolutely yes. Now, this is a very interesting one, right? I need to find out, and this is from IPMAT 2024, so just the last year's paper, where it says 4 raised to log x to the base 2 minus 4x plus 9 raised to log y to the base 3 minus 16y plus 68 is equal to 0. I'm just looking at my notes here to see where the problem is. Okay, easy. So the tough parts of this problem are the two logs. Let's break them down individually. So if I take 4 raised to log x to the base 2 is equal to a, then what can I do for this particular thing? I can say that log of x to the base 2 is equal to log of a to the base 4, because 4 raised to log x to the base 2 is a, right? And this can be written as log x to the base 2 is log half log a to the base 2, because 4 is 2 square, so the 2 becomes half outside. So I get the value of x is equal to a raised to half, or I get a is equal to x square. Great. Similarly, if I take 9 raised to log y to the base 3 is b, then I can write log y to the base 3 is log of b to the base 9. 9 raised to this is b. So log of y to the base 3 is 1/3 of log of b to the base 3. So y is equal to b raised to 1/3, or b is equal to y cube. Now, how do these expressions help me? Do they help me at all? Absolutely, right? I had assumed that this first expression is a, and that is x square. The second expression is b, which is y cube. So I can rewrite it as, this is nothing but x square minus 4x plus, this is y square, sorry, y square minus 16y plus 68 is 0. Easy. So x square minus 4x plus 4 plus y square minus 16y plus 64, and 4 and 64 68, so I don't need to introduce any terms. So this is x minus 2 the whole square plus y minus 8 the whole square is equal to 0. And I know that when the sum of two squares is 0, each individual term must be equal to 0. So that means x minus 2 is 0, y minus 8 is 0, which means x is equal to 2, y is equal to 8. So y minus x is 8 minus 2. My answer is 6 and I'm done. So a fundamental problem of logarithm where you have to understand that assuming each log expression as a simple variable and resolving it will actually lead you to the final answer. So a great question, but prima facie it seems tough, but if you analyze it carefully and do it step by step, it's absolutely easy, absolutely crackable, absolutely can be done. So those, dear friends, were my top 10 questions from IPMAT, right? 21 to 24, I think, yes, 21 to 24 were some of the papers from which I had picked these questions. And because these are short answer questions with no negative marking, you can absolutely take some risks because all you're going to lose is some time. Even if you get the answer wrong, you're not going to lose any marks. It's just some time, and because each section is timed, you cannot anyway use the time for the next section. So it's definitely worth taking the risk, spending some time on each of these questions and cracking them. And believe me, because a lot of these papers seem to have almost the same type of questions as far as the basic fundas are concerned, it is absolutely essential that you take a look at the past year papers of IPM from the official website. Many of these papers are available, or you can go online and search. Go through all these papers, work out these solutions, understand the funda behind them, and believe me, the IPMAT of IIM Indore is an absolutely delightful paper to crack. So this is me, Sathya from IQ Ideas, signing off. Please do subscribe to our channel, IQ Digital. Do like, share, comment, whatever you're supposed to do on social media. I have put a lot of solutions to IPMAT questions and questions from other actual papers as well. And keep following us, keep a track on us online. I'll be coming up with more of these videos. Do send in your comments on our social media in case you need assistance with any specific question or some general information. I have launched a couple of self-learn modules for exams like the PDEU entrance test and the Symbiosis SET general entrance test. So you can go on my social media and check out the links on where you can purchase these courses. We also offer physical courses at our center here in Ahmedabad. So in case you are looking for entrance examinations like the IPMAT or SET or CUET paper 3 or PDE or any of these general aptitude tests, and by that I mean tests which contain English, Maths, Reasoning and GK, then please do get in touch with us and we'll have fun and we'll make sure that you work hard enough and have an ample amount of assistance to crack these entrance exams. So here's me, Satyanarayan, wishing you all the very best and have a fantastic life.